Welcome back. We're just going to take this video to finish off the question that we started in class on calculating the distance from a point to a line. So we'd set up this problem where we had a point here in space, 2, 4, and we were interested in how close this point was to the line connecting these other points 0, 1, and 4, 3. And by how close we mean if we drop down a line perpendicular to this other line, i.e. at right angles to it, what is the distance d between our point and this line? And the way we've gone about it was by sketching a few vectors into our picture so that we can start applying some of our new knowledge about vectors to it. So first we drew on this vector v, and we know how to calculate that. That is v, treating our points as vectors, is going to be 4, 2 minus 0, 1, which will be now what am I doing? 2, 4 minus 0, 1, which is going to be equal to 2, 3. Okay, that's our v vector. We then drew on u. We're going for the easy things first, ones that we can easily read off. So we're going for u is going to be this vector here, which connects the points 0, 1 to 4, 3. So u will be 4, 3 minus 0, 1. Again, treating our points as vectors, we can just use that difference formula. Will give us 4, 2. We could also have read these vectors straight off our picture just by counting squares across and up for each one. Now the third vector we want to add in is the new one we learnt about, this projection here, and we'll call that p. So p is a vector in the same direction as u, but it stops at this point where this perpendicular line is going to be dropped down. And p will be the projection onto u of v. And then once we've got that vector there, we can finish off by calculating this vector which connects v and p up and then finding its length, which will be the answer d that we're after. Okay, so I'm just going to clean this picture up a bit because it's getting a bit messy. What we have is these vectors here that we need to calculate. We've got u, we've got v, we want to calculate p, and then v minus p, and then find the length of v minus p. So let's write down our formula for p. So p is equal to the projection onto u of v, which equals u dot v over u dot u, all times u. Now u dot v will be 4 times 2 plus 2 times 3, all divided by u dot u, which is 4 times 4 plus 2 times 2, all times the vector u, which is 4, 2. Okay, simplifying that slightly, the top row is going to be 8 plus 6 is 14, and on the bottom we're going to have 16 plus 4 is 20 times 4, 2. And I can simplify that slightly by bringing a factor of 2 outside of my vector and then simplifying the fraction. So it'll be 28 over 20, which will become 7 over 5 times 2, 1. Okay, the simplification is just to make things look a little bit nicer. We could have left it in the form we had it before. That would have been fine too. Okay, so that's our vector p. Next one we want is v minus p. So v minus p is going to be 2, 3 minus 7 fifths times 2, 1. At this point, if you like, you could convert it to decimals and just work that way. I'll leave it as a fraction just because. So I'm going to be working with fifths here, so I'm subtracting 14 fifths off the top, and I guess 2 is 10 fifths. It's going to be something like -4 for this one. You can check this algebra yourself in your own time. Maybe even pause the video and just double check I'm doing this right. And on the bottom we're going to have 15 fifths minus 7 fifths looks like 8 fifths. Okay, so that is our vector v minus p. And finally, we want the length. In fact, let's bring a common factor of 4 outside of this one as well. So 4 fifths times -1, 2. We can sanity check our answer by just checking that it looks right. It is going left a bit and up a bit more. That looks kind of consistent with our picture, so we've probably got it right. Last thing we want to do is to calculate the length of this thing. So the length of v minus p, which is the d we were after, is just going to be the length of 4/5 times -1, 2. Now remember, we can bring scalars outside, so it's going to be 4/5 times the square root of 1 squared plus 2 squared, which happens to be 4/5 times root 5, which if you like is 4 over root 5. Which if we convert that to decimals, I'll just give you two decimal places, is 1.79 to 2 decimal places. Okay, and if we look at our picture, that looks about right. It looks a little bit less than 2, so we've probably done it right.